Hello everyone. I want to welcome each and everyone to our group Conqueror. Me and my colleague at Conqueror have been waiting for this opportunity to showcase our project proposal for a long time now. Presenting to all of you, Alokito Technology. So what exactly is Alokito Technology? Alokito Technology is a vision, which we both at Conqueror have been seeing for the past 1 year. Let me guide you to experience our imagination. Our vision is to create a speech emotion recognition using machine learning model, which we are going to use to generate primary emotions, and from there, get the secondary emotions by our own created algorithm. What is this algorithm many of you have already started to think I see? Ha ha ha. Do not worry. Let me explain. Think like this. How do you make the color green? Think for a second. Yes, that is correct, mixing blue and yellow. Similarly, using the ML model and getting primary emotions, we will create secondary emotions to give an extensive idea of someone's voice. Our primary goal is to integrate this model and our solution to our Seneca counseling department. This feature will give our counselors a first-hand knowledge of what a student is going through, so that they can help and guide them even before the counseling starts. This project idea didn't just emerge overnight all of a sudden. There has been a relay of events in our academic journey which made us select and undergo such a hefty task like this amidst the last semester. Me and my colleague both are a firm believer of achieving something by working for it. Success overnight is just a myth. Having said that, we wanted to integrate all the resources we had so far and went even further in learning something more. For instance, AI and ML are not taught directly in our program. We wanted to take courses of such kind, but of course, it was not available. We tried to contact various other departments at Seneca. Well, no luck. Did we give up? Nah. We dedicated some extra hours learning new things such as developing algorithms, integrating existing ML models, creating pipelines connecting one MCU to other, using Flask and whatnot. This gives me goosebumps at times, but looking back, I feel the journey so far was totally worth it. However, this was only half the way.
We found what we have. We knew what we can do in this field. We did not want to settle for less. We knew it would not be easy. However, we were up for this challenge. This project is dedicated for the well-being of students at Seneca, as mental health is the most important factor in today's date, and we wanted to address it with all our might. Let's break the block diagram into two halves. Left side we have the backbone of this project, which my friend fancies to call it web server, model, file server, bridge, and whatever you want to call it. What happens is, the student walks into our website to book an appointment, enters basic credential like first name, last name, and student number. After that, the student proceeds to record their voice in order to book an appointment. If all the necessary checks are satisfied, the data with all the information is sent to the next stage for analysis, followed by storing of data locally in the server. If there is any error in student number or improper audio capture, the website will prompt to redo it again. This check is vital for safety and verification of actual students. If all checks are passed, the student gets a message that the appointment schedule will be sent shortly.
Then the data passes over to our other MCU, which is primarily set up for verifying output and acts as a feedback unit for our project. I call this unit a Fine Hardware Interfacing Module by ESP32S. I hope you like it. What it does is once the data is received, Buzzer provides feedback, LED prompts with all the necessary step checks, speaker calls out the student name alongside other information using Google Text to speech, and lastly, some key information is showcased using the OLED display. Now this is what the electrical design is looking right now. Notice that the Raspberry Pi 4B is just there to act as a web server and file server, and does not participate in the main hardware interfacing. The data is then sent wirelessly to ESP32S. From there, the ESP32S smoothly does its job, which I mentioned. Fine hardware interfacing. Ha ha ha. Speaker, feedback display. Feedback, LED, feedback, buzzer, check.
We have the following input device. Push-button switch for interfacing with the display knob, which is integrated with the amplifier for the speaker microphone. This is the most important input device as it uses end-user device Qing student's input module to send the key data on-off switch, turning on-off ESP32S. The output devices consist of the following. Speaker. Integrating a speaker was really difficult. My friend and myself both had hard times to do so. Firstly, latest ESP32S3 does not have DAC ports. Why you do this? Aha! Anyways, we used ESP32S, as old as gold we all know, and it has DAC port. You ESP32s. Later we figured out how we were chickens, as only speaker would not work. We need a dedicated amplifier. Guess what, we bought an amplifier, Athene X, to my friend. It is what it is. Well, it works, so GRT job OLED display. This we used as our another feedback device, as the colors are really vibrant chroma pred to ugly-looking LCD segmented displays. LED. This will give us an idea on the stages of data processing and receiving. Buzzer. Treat this output device like the whistle during the beginning of a race. When it is fired, that means data has been received for showcase.
I cannot believe that it took us a week to decide which IoT dashboard we will use. Well, finally, we both agreed to work on Tago.io, right?
Right, can you continue?
Anyways, as I was saying, Tago.io is one of the best open source IoT dashboard, which is just too good for our module ESP32S. This is because of the following reasons. Supports dynamic widgets. We will get to say charts if we can make it happen, like emotion analysis and whatnot. It is secure, offers role-based access control. By integrating this Tago.io, we aim to both control and monitor our system locally from anywhere.
Let's talk about the first challenge in the segment design phase. First thing we encountered was integrating the primary emotions into secondary emotions. We got the output, however, it still lacks some polishing. As of today, there are some data leaks which me and my colleague are trying to repair. Secondly, our UI/UX design. Not gonna lie, but designing and web development is not our cup of tea. However, we both are getting assistance from YouTube videos, and fingers crossed by the time we will have some basic to intermediate level UI/UX design, which will be presentable for the students and the users as a whole.
Second phase challenge is engineering phase. Right now, an average clip of 30 seconds is taking close to 1 minute for the analysis. This is one of the things in our bucket list to fix it as soon as possible. At least we will make it streamlined for the user end and then later work it out for the server side. Lastly, our networking and connections. Oh my goodness, can you believe it that we are currently running ESP32S IoT, Raspberry Pi, and local server and testing for the releases all under our mobile network sharing. If one single connection gets ruptured, that means we are pretty much doomed. Therefore, we have to take a look at that for fixing.
And yes, finally, the last challenge and the scariest one for real. Manufacturing phase. When it comes to hands-on engineering and soldering, for instance, me and my colleague are just an amateur. Yes, no shame in denying this. No surprise that we are rushing to get our part done, which we consider as our strengths, as soon as possible, so that we can start messing with the soldering sessions, which I am pretty much sure will take some million years, if not billion. Hardware compatibility is definitely challenging. As we mentioned before, ESP32S has certain OG ports which ESP32S3 lacks. What a shame! Speaker needs amplifier for better audio output. We do not have any problems to buy and incorporate, but the logistics and shipping adds up to the time and testing. For the hardware enclosure, I am having a debate with my colleague what to choose between plexiglass and wood. Both has their own advantage, but we will surely choose it soon in the upcoming days and showcase our skills.
We have plans to fix those, however. We will work hard in polishing the existing algorithm with our professor's remarks, and will make sure it works out. Also, for the UI/UX, we will continue learning some basic and intermediate designs to address this knowledge gap. We will try to streamline this part by making it smoother at least for the user's end, and we'll see if anything can be done to improve the back end. We have not tested out yet Out IoT dashboard, but we'll see if there are any tools specially to monitor the network connectivity for any improvements. Lastly, we will seek for expert mentorship if possible, and if not, then we'll try until we reach the required results for our PCB soldering and connections. We will end the debate for choosing the enclosure material soon by selecting the one which would be easier to configure and other factors.
Till now, thanks to DigiKey and Amazon for helping us out with timely supplies. Other than that, shout out to 11 Labs for excellent voiceovers, and thanks to Adobe Rush and Microsoft PowerPoint for making this proposal streamlined. Last but not the least, I want to take a moment to thank Pixabay for excellent non-copyright clips for this video segment. Thanks a lot for taking time to go over our proposal.